Okay, so welcome to week 6, and this week we're going to go over homework 3. All right, and I got to get the right homework here, not the lab. There we go. So this packet tracer utility is really important because this is the cornerstone of how access control lists are written. So if you listened to lecture last week on ACLs, I went over the syntax and the application of access lists on a router. And again, we're only talking about them being placed on a router. We will also look at the implementation of the two different types of access control lists with IPv4, standard and extended access list. It's very important that you understand how ACLs are written and applied because they're not only used for filtering of traffic on interfaces, they are also used for things such as identification of interesting traffic that can be used for a multitude of other applications, like what we're learning this week with zone-based access controls, or ZBAC. They can be used within policies to identify traffic for those. They can also be used for identification of traffic for other types of applications, typically quality of service, which is tied to voice applications and other things that can pass through a router. So let's go ahead and get that opened up. So hang in there with me today because there's a long list of activities in this homework, and you need to go through the entire activity first and then come back and troubleshoot. I even said that in lecture this week because like in what we've done in the homeworks previously, where we have done a little bit and then went and checked on our progress and done a little bit. It's kind of set up to where they do certain activities and then they change stuff and they kind of look at it at the very end, if that makes sense. So you need to kind of wait to the very end to check your results. Because if you go through and you try to troubleshoot, oh, why didn't I get the points for this? Well, it's because it's later on in the lab they change stuff. There we go. Okay. So as we open up the packet tracer activity, the homework here, let's just kind of briefly read through everything we got to do. So looking at the topology, let me bring that up real fast. We have 3 routers, R1, R2, and R3, 2 switches, and then a couple of a PC and a server. Okay, we're going to be doing ACL work on all 3 of these routers. All right, so the first step is just basic connectivity. We're going to skip over that for the most part. And we're really going to get into doing the work of this assignment in part 2. So in part 2, we're going to create a standard ACL on R1, R2, and R3. In part 3, we're going to create a extended ACL on R1 that is going to permit certain types of traffic to the server. Okay, we're going to apply all those. And part 4, we're going to modify the existing ACL on R1. So this is when you get into that change that I was talking about later on. And then part 5, we're going to create an extended ACL on R3. And in part 6, another extended ACL, numbered ACL on 3 as well. So it's a pretty lengthy assignment. So let's get to it and start looking at this from part 2. Okay, so they have all of the different login names and everything else. So we're going to be working on R1 at first. Actually, all 3 I think ACL 10 blocks all remote access to the routers except from PCC. So we just need to make an ACL and then apply it to the appropriate interface, which most closely faces PCC. So let me bring up R1, R2, and R3. Okay, so let me show you a little trick here. And I don't show this to very many people. You see how they have a password? I love Packet Tracer because it's so hackable. If I want to get past all this, I just need to go to the config, select an interface, any interface, go back to CLI, hit Control-Z, and I'm in privileged exec mode. All right, so I don't have to put in all the username and password. You can put in the username and password if you want to. I mean, on a real device, you would have to do that. But for the convenience of time, I'm going to go ahead and do that here real quick. So again, the config tab, select an interface, any interface. You go back to the CLI. It bypasses, hit Control-Z, hit enter, and you're in privileged exec mode. Okay, you really want to just jump over everything. Let's see, R3. I think I have to go to R3. So you see how I did that. If I go to config and then interface and then back to CLI, I'm already in interface config mode. I could Control-Z back, but then I'd have to hit enable. Then I'd have to type enable and then the enable password. Here I just have to hit exit, and I'm already in global configuration mode. So one just real quick shortcut with Packet Tracer. This is one of the things that teaches bad habits, of course, especially around security, but for learning purposes, it's all right. Okay. All right, so let's go ahead and create our ACL 10 access list 10. And going back to the instructions, we're going to block all remote access to the routers except from PCC. Use an access list command, all right, to create a numbered IP ACL on R1, 2, and 3. Okay, apply the ACL to the VTY lines with the access class command, and then verify that only PCC can access A and C. It can access the routers, and make sure that PCA should fail. So again, we're only dealing with SSH. SSH it doesn't matter what the port number is of the protocol, because again, a standard access list only looks at what? Source IP for its determination of filtering traffic, right? So we don't have to worry about protocol. We don't have to worry about it. It's using SSH, because since we're using a standard ACL, okay, it's just source IP. So let's look at the IP that we're in question. PCC has an IP address of 192.168.3.3. Okay, so somebody remember that, or I need to write it down here behind me. .3. Okay, otherwise I'll forget it later on. All right. So on let's do R3 first, since it's closest. Access dash list 10 permit, and then the IP address. Okay. Or we can use host to designate that it's a single IP address. All right. Okay, and then there's what behind it. An explicit deny all, right? Now, remember, where are we applying this to? Are we applying it to an interface? This is for remote access. Are we applying it to an interface? No, we're not. So we don't have to worry about blocking other traffic. It's going to be applied to the VTY lines. So there's nothing else we really have to do for this ACL, because we're telling it, look, only this IP is allowed, nothing else. So now let's go to the VTY lines. And type in an access class command, the access class number, and then the direction it's coming, which is going to be inbound. All right, that's it. So that applies that access list to that line, are those virtual terminal lines, right? And only PCC now can log in via SSH to that router. You repeat the process for R2 and R1. Access list 10 permit line VTY04 access class 10 in, and finally R1. I started that one already. Permit 92.168.3.3 line VTY04 access class 10 in. Okay, that basically will take care of part 1. Okay, so with part 1 done, or part 2 done, excuse me, we're going to move on to creating this ACL on R1. So I'm going to make this a little bit easier. Just bring up R1 where we can see everything. And we're going to permit any outside host to access DNS, SMTP, and FTP on PCA. Deny any outside host access to HTTPS on PCA, and permit PCC to access R1 via SSH. So with that, let's just take a quick account of what we got to do. All right. I suggest that you go through creating your ACL one line at a time based on the requirements that they're laying out. The only difference is if you have to deny something, you typically want to put that up front at first. But I don't know if they've updated this in this version of Packet Tracer. The last time I tried that, it failed. You don't get the points. So it's best for the Packet Tracer part to do it in sequence that they lay out so you get scored correctly. Okay, but in essence, as a best practice, you see where they say deny outside host access to HTTPS. You would put that deny statement at the very front of your ACL. Okay, so let me get out of the line on R1 and create the access list. And this is access list 120. And then it wants me to permit any access to DNS on PCA. PCA is 192.168.1.3. So the source is any. The destination is host 192.168.1.3. And EQ, which is equals what? DNS, right? Oops, it didn't like that. Well, there's no DNS thing. So what's the number for DNS? 53, right? So that'll take care of zone transfers. But regular lookups, they don't use TCP. They use, what's the other protocol? TCP or UDP. So all we have to do is change that from TCP to UDP. And I think this one, if we delete the 53 and hit question mark, oh, it's still not there. Just SNMP and TFTP. Well, that kind of stinks. We're going to put 53 there as well. There we go. All right. Going back to the lab. All right, so we got to do the same thing with SMTP and FTP. Now, SMTP and FTP both use TCP. So if we go twice, all we have to do is change that last number to SMTP and FTP, and that'll take care of it. Deny any outside host access to HTTPS on PCA. So the next one, instead of a permit, you see how I'm editing this? So I already have a lot of it done. I'm going to put deny in there. HTTPS is TCP, any, same host, but this time, oh, I don't have HTTPS. So what's HTTPS's port number? 443. Good job. There you go. And then permit Pcc to access R1 via SSH. So this time we had to do a little bit different. So let's go back to one of our permits. This time it's not going to be in anybody. It's going to be another host. 3.3 is PCC. And then the protocol is SSH. Let's see if we have SSH in here. We do not. So SSH is what port? 22. I did check that, so that's done. So that's how you get through that initial, how do I set up my ACL? It's very granular. You need to do it step by step by step by step. Okay? Be sure to disable HTTP and enable HTTPS on PCA. Okay, so I need to then go to PCA. Make sure that HTTP is disabled and HTTPS is enabled. So I think that's under the Services tab. HTTP needs to be disabled. HTTPS is enabled. So there we go. That takes care of that step. Use the access list command to create a numbered IP ACL. We did that. Now we need to apply this ACL to S000. So going back to R1. We go into int S0/0/0 and we apply it, the access, I think it's the IP access-group command. And it should be inbound on S000. So this was ACL 120, and that would be inbound. There we go. Then you can go through the verification steps through packet tracer. I'm going to skip ahead here real quick. So modify the existing ACL on R1. So what we need to do now with this ACL is permit ICMP echo replies and destination unreachable from the outside network relative to R1, and deny all other incoming ICMP packets. So let's go back and look at the topology. So here's R1. So we applied the ACL here to this interface, okay, for traffic coming in. We're going to go back into that, and we're going to allow certain ICMP traffic and then deny other ICMP traffic based on what the lab calls out. Okay, so I'm going to exit out of the interface, go back into global configuration mode. Then I'm going to type in access -list 120 permit ICMP, which is the protocol, and they want you to permit ICMP echo replies and destination unreachables. So that's going to be from anywhere. Okay, and they did not specify a destination, so I'm going to assume it's to anywhere. So permit ICMP any, then I question mark that. There's echo reply. I do it again and make that destination unreachable. So they don't have destination reachables. They have host unreachable. Well, we can try that. I guess I could just put unreachable. Yeah, I think it's just I think this is one of those tricky ones as well. So let's just do unreachable. Okay, and that modifies it. So now if I exit out of global config and I do a show run, hopefully I will see all of those set up in my ACL that I have written. There it is. Okay. So I have my domain, my SMTP, FTP, 443.22, and all my ICP. Ooh, I missed something though, didn't I? There's one other thing in that. Deny all other incoming ICMP. So remember, access lists go in sequence, right? So we've already permitted what we want to come in on the ICMP. So if we put a deny ICMP any here, we're good. Does that make sense? Because all the stuff that we want to come in would hit that ACL first, and anything else, say on an ICMP packet, would get denied. So let's go back into global configuration mode. And you see here where they have permit ICMP any. We're going to change that permit to deny. We're going to not put anything after it. We're going to put deny ICMP any. Now, do a show run. Let's go look at our ACL. And that ICMP, deny ICMP any is at the end of it. That's good because it goes in sequence. The echo reply and unreachables will work. Anything else will get dropped. Everybody understand how that flow works? Good. Okay, moving on. Part 5, create a IP ACL 110 on R3. So let's go to R3. We're going to deny all outbound packets with source address outside the range of the internal IP addresses on R3. Whoa. Okay, we're going to break that down a second. So we're going to use the ACL access-list command. We're going to apply it. So this is kind of convoluted. This is kind of a tricky statement here. Deny all outbound packets with source address outside the range of the internal IP address. So that means we have to permit some stuff too, right? So here's R3. So what's outside and inside? This is outside, and this is inside. Okay? Outside, inside. Let's read that one more time. Deny all outbound packets with source address outside the range of the internal IP address. So what we have to do is basically create an ACL with the source of the local LAN, and then we can do an explicit deny or an implicit deny, or we can just let it go. This one is a little tricky because you have to kind of play around with it to make it work. So the internal address is 192.168.3.0. Okay. Permit 192.168.3.0, and it takes a wildcard mask, which is an inverted subnet mask, so that would be 0.0.0.255. And we've got to specify IP, excuse me. Got to specify the protocol. And then destination is anywhere, right? Okay. So that basically says that, hey, any traffic from this subnet is allowed to go anywhere. Okay. Everything else should be an implied deny all. So what we have to do here is we got to figure out where we got to apply it. So they want you to apply it to incoming traffic on F01. F01. So if we go to int F0/1 and we do IP access dash group 110 in, that should do it. Okay. Now, again on R3, we're going to create a numbered ACL 100 and block all packets containing the source IP address from the following pool of addresses. 127, everything from RFC 1918, and any IP multicast addresses. All right. You're going to create the ACL, and then you're going to apply it to incoming traffic on serial 001. Okay. In this activity, your internal address space is part of private address space specified in 1918. So be careful here. Should also block traffic sourced from your own internal address if it is not an RFC 1918 address. If it is not, okay, and then your internal address is part of your private address space. This gets a little convoluted here. Okay, so let's try to give this a shot here. Access dash list 100 permit deny. Let's do the denies first. Deny IP 127.0.0.0 0.255.255.255 is a /8. Okay. Destination any. Next one. We're going to deny IP on any RFC 1918, but we need to permit our own one first. Okay. So we need to permit our any return traffic You should also block traffic sourced from your own internal address space. Okay. Our own internal address space. That's really weird. So I guess that's fine. We're going to deny 192.168.3.0 0.0.0.255. That's our own address space we wanted to deny as well. Okay. And then we want to deny the rest of multicast, or I should say the RFC 1918. We want to deny the 172 block. Wait, 0.31 or 15? Dot 15, yeah. Had to do that binary calculation in my head real quick. And then the 192.168 full Class B. Okay, and then multicast, which is really easy. It's just 224.0.0.0. Okay, that'll take care of that. This is the one I always goof up on and never get all the points. Then we have to apply that ACL on F01 inbound. So int F0/1 IP access dash group. That is, I think I goofed that one up. Serial 0001 inbound. Almost goofed that up. Int S 0/0/0/1. 100 in. All right. A lot of work, isn't it? So now that that is all done, we can go and check our results here and see what we got to troubleshoot as to what we got wrong. Well, looks like we got one thing here wrong on 120. One thing wrong on 100. So we need to troubleshoot 120 and 100. Never get all these things right. Yeah, it's little idiosyncrasies like that that are really crazy. Oh, really? On the TCP or UDP? Because I have domain in there. It changed it. Yeah. Yeah, check my work here. Yeah, we're gonna pause this real quick. All right, so we're gonna resume this here just so everybody has a take on what 120 looks like on R1. That's what you should have as your ACL. And then 100, which is on R3. Should look like that. Okay, so I think mine was pretty close. We'll see where I went wrong. Again, it's wonderful to have an answer key, right? We'll see where I went wrong. Oh, I missed the permit IP any again. That's what it was. So 110 and then 100 any. I had them in the wrong order. I didn't need to have this one in here. I didn't have the permit IP any. I did have everything else right though. I had the RFC 1918 right. I had the multicast. I had the host in there. 127 that was in there. So let's see if I get this right. Copy. And then we'll paste. Oops. That looks good. That looks good. Maybe I have to close the router for it to like catch up or something. I don't know. Oh, it liked my 100. Still doesn't like something on my 120 though. Well, I don't know why, but that is the right layout for 120 that I showed you guys. Maybe if I save it and come back into it. No write permission. All right. Anyway, that's that. So you guys have the correct syntax for that ACL. So we're going to stop the video here.